Hello, everyone. Thanks for joining. Hopefully, y'all can see my screen now.
Yes, confirm.
Okay.
Yep.
All right. So if you have questions, please put them in the chat. I've got lots of different places that we can stop and we can talk about them. So feel free to put those in there. If I'm looking off this way, it's also because that's where my chat window is. But I'll have Andy help moderate as you have those. So first of all, thank you all so much for coming. I hope y'all are having a great Data Geek Saturday. So we are here to talk data integrity demystified. So who am I? For those of you who don't know me, my name is Deborah Melkin. I've been a database professional for 20 plus years. It's a strange number, but it's true. I mainly work with SQL Server, although I've done a little bit with other relational databases. So, just enough so I can do some damage. I mainly work with transactional databases, but I've done a little bit with warehouses and marts, just enough so I can do some damage. I'm a board member of the New England SQL Server User Group. We are the Greater Boston Area SQL Server User Group dealing with all things Microsoft Database Platform. I speak at other events in the database platform community for the Microsoft. I am an IDERA A's class of 2020, so thank you to IDERA for having this program for up-and-coming speakers. If you remember past summit, the last past summit in person, I won speaker idol, woohoo! And last November, I was honored by Microsoft as an MVP of the data platform. I'm still very humbled by that and still hoping I'm doing enough to deserve that title. So I'm very humbled. Unimportant stuff, the really important stuff, to know about me. I'm the alto section leader of my choir. I attend bluegrass jams regularly. In fact, I'm missing my regular jam right now. I don't know, maybe I'll try to hit it a little later. We'll see. But I've been learning guitar. I have a mandolin I'm neglecting. I'm kind of a musical theater geek. And I'm so thankful that many of us are getting vaccinated so we can actually start doing these in person. But please be safe out there, wear masks, and these variants are getting a little scary. So please keep safe. And we'll get there so we can then start doing these in person because I can't wait to present to y'all in person again as well. So why are we here? We're here to talk data integrity. So here's the agenda. So there's a lot that we build upon when we create data integrity, and everything builds upon each other. So we're going to take a step back and we're going to talk about how we build that. And the nice thing is a lot of what we do already puts in that data integrity. And we're already doing those things. So if you're an experienced database professional, a lot of these things you'll be like, yeah, I know about that. Yeah, I know about that. But I want us to take a look at them from that different perspective, and we'll get a little more appreciation of them, maybe. But we also can really get to appreciate the importance of these and what all of these different things mean for creating data integrity. So we're going to start by setting a foundation. Then we're going to talk about how we're designing for the data so we can really build that in for integrity. And then I think we'd be missing something if we didn't go in a little bit about how that integrity and performance work together. What's really about performance, what's really about integrity, and really thinking about those two and what they mean and how they work together. So let's jump in. You got to start by defining integrity. And I think that's the biggest thing. We talk data integrity. It's big, it's lofty, it's very full of goals and all those sort of things. So let's break it down because I think as we start looking at it, it isn't as much. It's a lot more accessible than what we think. So I like definitions. So we're going to start with what's the definition of integrity? So if we look at Merriam-Webster's definition, there are a couple things here that I think apply to data, such as, the number 3 here, the quality or state of being complete or undivided. And when we talk about integrity, especially when it comes to data integrity, this is going to be a really big key. So now let's talk data integrity and the definition. And for here, I went to Wikipedia. The maintenance of and the assurance of the accuracy and consistency of data over its entire life cycle and is a critical aspect to the design, implementation, and usage of any system which stores, processes, or retrieves data. So we talked about integrity being completeness. Now, once we think data integrity, I love the idea that we're talking about the life cycle of a data. Our data does have a life cycle of how it lives in how it lives in our database. When I do a T-SQL 101 and I talk select, insert, update, and delete, and there's a life cycle. First, we insert our data, then we make sure it's correct, then we update it. And at a certain point, we may not need it, so we may delete it, and then we need more data. So as we think about how data moves and how we interact with data in our tables, you really do see that there is a life cycle to the data and how we change it and how we interact with it. So, and thinking about how that works gets into how we design it, how we're implementing the usage. And we're also thinking about anything that stores, processes, or retrieves. So that really kind of broadens everything. But if I wanted to simplify it, it really comes down to this. I have this cell here. I have this field, this data in a field, this one. What does this mean? And for me, that's really the core of data integrity. I have data in a column on a table. I need to make sure that we protect that. That one always means something. And whatever it means, we can guarantee it through whatever value is in that field. We want to make sure that it maintains that meaning and it maintains its integrity throughout whatever else we need to do in that system. So we can pretty much guarantee the quality of our data. So why all of this stuff matters? Usually I like saving this towards the end, but since we're talking data integrity, I want to start about why it matters, why we want to think about things before we even get into it. So the biggest thing is garbage in, garbage out. If you can't trust the data going into your database or wherever you're storing data, how can you trust it when you pull it out and you need to work with it? You have to be able to trust your data. And there's so many different places we talk about how we have to clean data and all of those sort of things that go around it. So we're making a lot of work for ourselves if we can't trust the data that we have. Because it's also not independent of other data. I showed you one field on a row for a table. Well, what does that mean by itself? It interacts something else. And so we need to understand what those mean so we can make sure that that one field has that one actually means something. This is another big thing, and I think people forget about this. You have data that's accessed by multiple sources. I love it when I have a conversation with a developer and they're like, yeah, well, we don't need to worry about that because the application will take care of everything. The application will enforce X, Y, and Z. And my comment is, okay, but you're forgetting something. How do we roll out database changes? Oh, well, we create scripts for those. So that's a second way of accessing data. There's and we start reminding that there's more than one ways to do it. We may start creating reports off the table. There are multiple things that access our data. And however it's being accessed, we can't guarantee it's only going to be the application. We cannot guarantee that it's only going to be someone in a script accessing our data. So we need to make sure that whoever is accessing our data can access it the same exact way, and we can guarantee that however it's being written to will be the same. And we have the basic constructs that will help along with that. Because this is going to solve problems before they happen. Because if any of you have had to deal with cleaning up bad data afterwards, y'all know it's a problem. It's a pain. It's very time consuming. And you start eroding everything else that we've been trying to do. It gets back to we have garbage data. We can't trust our data. It's just a mess. And data integrity is really making sure that that just doesn't happen to our databases and to the data that we're dealing with. So let's start by setting the foundation. So what do I mean by setting a foundation? Well, first, we want to talk about where our data is stored. I'm used to dealing with databases, so that's how I think about it. So when we think about data storage and data engines, that's the first thing. Where is our data? So obviously, we're a Microsoft Data Platform Conference. We talk about SQL Server. We talk about our relational databases. That's kind of the first place we store data. But there may be more than one place that we need to deal with data. Let's think of, there's so much else across our data ecosystems these days. We have NoSQL databases. We may be dealing with things like Mongo. We may be dealing with Cosmos DB. We could have data lakes. So now we're starting to get to Internet of Things or different structured data that we're all dealing together, and we need to have it work the same way. Excel. I'm not saying Excel is a database, don't get me wrong, but how much data are we still dealing with in Excel? You may have to import Excel worksheets into somewhere. Rob Sewell has this great presentation on dealing with Excel and PowerShell and all of these sort of things. It's import, it's where data lives that we may need to work with. Even text files. And when I say text files, I'm not even talking about the format of data inside the text files like JSON, CSV, XML. We have a text file and this is where our data lives. And those are just a couple examples of what we're dealing with. So the first thing we have to understand about our data to build the data integrity is, where is our data coming from? Where does it live? Because then we can understand a little more of how we need to work with it. So now we get into things like naming conventions. And there are a couple of different ways we can name things, and things that are always up for debates. Things like capitalization and punctuation, things like character limits. At one point, Oracle still had a 30-character limit. I don't know if that's been removed in the past couple of years in the last couple of versions. But again, if you have something in Oracle and SQL Server, those 30 characters versus however, what's it? I forget how long at this point, but you get those different lengths and you have to deal with data across. So how you name things with those limitations, singular versus plural table names. That's something people will stand up on their soapboxes and preach about. um, Three-letter aliases and other prefixes, also using schemas and such. How are you naming your objects? Because there's nothing more frustrating than to find yourself in front of a new database and you're trying to find where data is, and you're looking at names and you're going, yeah, I have no clue what's in this table. I don't even understand the table name. What is this thing here? And it's a silly thing, but when you have good naming conventions, it's really easy to understand what's in that, what data you're dealing with, and what does that data mean. So a couple examples for naming conventions. um, Camel case, lowercase, underscore between words. A lot of this is more of a visualization, but it's really thinking about what you want to do. I do think being consistent in whatever naming convention you want is really important. We'll get to that why in a little bit, but it depends on what you find is readable, what you know to expect, how you can read it. Um, as long as you're being consistent and as long as it's something that makes sense, you want to work with it. You also have the idea of, well, as I mentioned, SQL Server allows a long number of characters in the name of objects. So you can technically name a table something like supercalifragilisticexpialidocious is 34 characters long. But if we think about naming conventions, what does that tell you about the table? What does that tell you about the data that you may be storing in that table? So you can make sure that that data is right and anything that needs to go into that table really does belong there. Or is long nonsense word a really more appropriate name for the table? You know, we in some ways I'm a very visual person, but it's also when you look at a really long name, who wants to write that out in a query? It's kind of why we use table aliases, but at a certain point, how does that help you understand what's in the table? Which I think is really important. Next is the singular versus plural. I actually do have a preference here. I actually do prefer single name, the singular version of words versus plural. And part of it gets into how I'm describing it to you. So I have one record in my gadget table versus I have one record in my gadgets table. Or it's one gadgets record. It's sometimes when you form sentences, when you form it with the plural versus the singular word in English, it can make it very complicated to do. And it has to do with how you refer to that single record. I have one gadgets. Wait, no, I don't have one gadgets. I have a single gadget. So it defines a single record. There's a whole bunch of ways that you can find out there that will explain it much better than what I just did. But again, whatever you're doing, as long as you're consistent, because when you're not consistent, you end up with something like this, what I call the history of names. So you can start seeing like the naming conventions that change over time, especially you have a really old legacy database, and then you start finding those columns that are no longer used because someone thought that you really wanted these three columns in every table, and then after a while you realize you dropped it. So why does it mean that it's here and then it's not? And then it just you can start identifying when columns were added based on the version or because that it was sent out with, because you see when the naming conventions change. And it means like if I have a new column for this table, I have no clue what to call it. How can I make sure that when you look at my table, you understand what these new columns are, or how you need to add a new column name? It's really confusing. And at a certain point, you don't want to be, yeah, whatever. It doesn't work, and it makes things confusing. So whatever you do, just be consistent. That's all I ask. So between the naming convention and data store and where the data lives, those are going to create the foundation. So just to kind of review, how do those create integrity? We're defining the structure of the data. Again, where is it being stored? Is it relational? Is it flat file? So on and so forth. Because of that, we can understand the type of data we're starting with. And then by names, we can easily understand what the data represents just by looking at the name. And then we can start creating that consistency and structure to the definitions we used in the database. We kind of hint at that with the naming convention, but really we're starting to create how we're calling things. And by saying what we're calling things and coming up with those names, we can start creating that consistency. So then anytime we see a column with that name, we understand what it is. And so then we can start enforcing the integrity that comes with that. So can start talking about designing for the data. I'm doing a quick check to see if there are any questions at this point. All right.
Nothing
So
that
Aaron,
I've seen it.
yeah.
Yeah, nothing at this point. Although Aaron did just chime in a little bit earlier, talking about how he also agrees that consistency is king.
Yeah, it really is. All right. So moving on, let's talk about designing for the data. So at this point, we're going to start talking about going into more of the relational database design. And a lot of what I'm going to start talking about may start falling under the logical construct. So you have a logical database design and you have a physical database design. So the physical is actually what you find in the database when you go into your tables and you see the structure inside the database. Logical oftentimes correlates with the physical, not always, but it's more of an ideal situation. This is logically what our database design looks like. Most of these things will correlate one-to-one. There are a couple things that don't as much, but we're going to start talking about those things. So when we talk about implementing the design integrity, there are a couple different things that we'll look at. We're going to talk about entity integrity, which is making sure the table integrity is intact, defining integrity for the table. We're going to mention referential integrity, so the relationships between the tables, and domain integrity, which is about the columns or the attributes. So as I said, entity is the logical idea, the logical implementation of a table. Attribute is the logical one of a column. But when we talk about database, we're talking domain, at least in this construct, we're talking about the columns. So let's jump right into it. So when we talk about entity integrity, I'm going to start off with relational design. So what are you choosing? Are you choosing normal forms or star schemas? I'm not going to get too much into the difference here, but if you stick around, Erin is going to be talking about normal forms, I believe, later. So you'll want to stick around if you want to get into table design. But I just want to mention whatever you choose, normal form or star schema, that's kind of the first thing we're going to do to create table integrity. And I don't think if you looked up table integrity, this is the first thing that you would see. But I'm throwing it in here because it is important. Like it is how we're defining our data and how we're going to enforce or help make sure that our data has that meaning and we can help enforce that data integrity and put it into place. More, not enforce, support, to support the data integrity. That's a better word. So we're determining how we're grouping our different pieces of data in a logical way. Because remember, normal form and star schema is all logical. When you actually put it in the database doesn't care. It just cares on how you're using it and if all the physical implementations are there. But this also starts providing those additional meanings in our data based on the column's role on the table. Are we talking about primary keys? Are we talking about, if we're talking about a fact table, is it a weight or measurement? Are we talking about if we're talking normal forms, does the column support the primary key? What role and how does everything interact with each other? So now we're saying what those columns relationships are on our table themselves. This gets into the concept of the primary key. So to review the definition of a primary key, it's a column or combination of columns that can define the uniqueness of each record on a table. So all columns have to be not null. You can only have one primary key per table. And again, this is where you start thinking about the logical versus physical. And we'll get into that a little bit more in just a second. But a primary key is essentially, what is this table about? So when I work with developers who are pretty new to table design and they don't understand the concept of a primary key, one of the things that I do is I have a question for them. And I think this is crucial, even if you are an experienced data person, to ask. We want to make sure we define our primary keys properly. So the question I always say is, so if you had to figure it out, what does this table hold using one or two sentences? And I think it's a really great way to figure out what the primary key is. So I have this table, this gadget order form. So if you asked me what a gadget order form would hold, I would say, well, it says a person for a corporation ordering a gadget on a particular date. That's what my gadget order form is, which is, and by that answer, I can say it's these 4 columns. So then I can take those 4 columns and I have now decided what the primary key of my table is. And it's a combination of columns, which is perfectly fine for what we're going to be doing today. So I've now defined my primary key. It's great. But we got to talk about a surrogate primary key. Remember I was saying logical or physical? So what I just talked about logically, that's my primary key for that table. But let's talk about surrogate primary key. And this is where I'm going to get in a bit of a soapbox. And the reason I do that is because of the word surrogate. So what is the definition of surrogate? And really, I want to go for definition number 2. I'm going back to my Merriam-Webster dictionary. It's one that serves as a substitute. This is what's really important, because I find a lot of times what we do is we throw an identity column on a table. It's auto numbering, it's integer, so it's slim. It's easy to make sure that everything's, we often make primary keys clustered, so it's ordered, great, nice, easy. We can easily identify each row as unique. But it's really a surrogate primary key. So how does it when we talk about data integrity, how does that identity column create integrity for the data on a table? So we have to ask ourselves, do they create integrity? And my theory is that they don't. I don't believe they do by themselves. It's because it's standing for something. It's a surrogate primary key. So if I had my order form, I've said that there are 4 columns that make it unique. But if I were to put an identity column on here and said that's my primary key, it doesn't help create that uniqueness that we need on this table. So there's this saying, if you stand for nothing, you'll fall for anything. I kind of want to adapt that. So if your surrogate primary key stands for nothing, your data integrity will, quote, fall. So what do I mean by this? We have an identity column, and I'm not against surrogate primary keys by default, because sometimes they're absolutely necessary. But what I do think is we need to remember the word surrogate. It still needs to stand for something. So if you're going to use surrogate keys, I highly suggest that you do something so you can help support that logical primary key. So I've got to use a surrogate primary key for my database design because that's what the developers need. It's how they use some object-oriented design, and because of however they're implementing these third-party tools, we have to put it, all right, fine. How can we have that surrogate primary key? How can we support our logical primary key? And this is where we start getting in the concept of unique key constraints. Now, mind you, you can have unique key constraints and primary keys. Like they're not mutually exclusive. You can have multiple unique key constraints. So going back to what is a unique constraint? It's a column or combination of columns that create a unique set in addition to the primary key. It is not as strict as a primary key because you can allow for null columns, and you can have multiple unique columns. Again, a primary key is unique, a unique constraint is unique, but you can have multiple unique constraints on a table in addition to a primary key. So you can have more combinations if you need. This is why oftentimes unique key constraints in a logical design model, if you're using a data modeling tool, you'll also see them call them alternate keys, because this also makes each record on the table unique. So it could also be a primary key. Now, there's a good question out there. If you have a difference, what's the difference between a unique key and a unique index, if there is? Because in SQL Server, primary keys are also indexes. Unique key constraints are also indexes. So when would you want a unique key or unique index? Kendra Little has a great blog post. I have it at the end of with my resource slides. But there are two reasons why you may want to use a unique index over a unique key. And this allows for the use of filtered indexes. So for example, if your table allows soft deletes, having a filtered index may help you, especially if that same record gets inserted and deleted multiple times. The other thing is for included columns. And this is where we start saying data integrity versus performance. Included columns would start not really for data integrity, I would argue, because the uniqueness is on your regular set of columns, but if you include columns, it can help performance. So it's just one of those things to think about, but it may help and may be a reason why you'd want to use a unique index versus a unique key constraint. But again, other than that, they both serve the same purpose, and it is to help define uniqueness in your records. So my gadget order form, I've got to use an order ID. I have to use my surrogate primary key, but now I can create my unique key constraint. So now I've got my logical key, and I can help enforce that business rule and help make sure that that combination remains unique, because that is also what I need to do to keep my data integrity for this table. So as a recap, what does entity integrity do? We start defining relationships between the columns on the tables, and in a sense between the tables themselves. You know, when we talk about star schema, thinking about what's a fact, what's a dimension, what's a bridge, so on and so forth. The other thing is we're starting to create a clear definition of what each record is about. So we have our table. What do we define as that table? We can use those unique constraints and primary keys to help define that. So again, we're creating all the alternate primary key combinations or logical primary keys when we use a surrogate primary key. And again, by having those extra uniqueness, now we're starting to introduce the idea of enforcing those additional business rules beyond just a primary key. You know, what makes everything really unique. Any questions at that point? All right. I don't see anything in the chat, so let's continue. Let's talk referential integrity. This one should be really quick, because I'm going to focus on foreign key constraints. If you're using graph tables, I think there is an edge constraint. I haven't worked with them, so I don't want to go into those, but those could also fall under the same concept of what we're talking about here. And that's how do we make sure the relationships between the tables are there? And that's what a foreign key constraint does. It defines that relationship. So we can start ensuring that the value in the field from the referencing table is in the referenced table. And so it can really make sure that connection. And when we talk about foreign key constraints, now we can start thinking about the actions that occur when the referenced column is changed or the row is removed. So what happens on an update? What happens on a delete? So now we have a way to link them together and say what we want to happen. And we can almost have the database define it for us and help us enforce it. Not always, but we can, because that's when we get into cascading foreign keys. So let's think about how those go into play and how we can think about what it means for data integrity. So I'm expanding my gadget order form, and we can now see the tables that it references. So I have a person table, I have a corporation table, and I have a gadget table. So now I have to think about when I order something, what happens if a gadget is discontinued? It's no longer available. Now I have to figure out what that means for my gadget order. And this is what we talk about integrity. How can I make sure my data order form remains intact? We can maintain the integrity of it, but still handle the fact that one of the things it's referencing is no longer there? Do we null out gadget ID if we remove from gadget because it's no longer a good the gadget's no longer there? Well, then we start losing what the order form is. So we've lost our data integrity. Do we delete the order form? Well, then we've just lost our history. We don't have order form. Our numbers, sales numbers can go off. Our reporting is off. We've just lost that. So we have to think about what that means. Maybe we just need to do something for the gadget table so our gadget order form can remain intact. So maybe we need to do something as simple as adding a discontinued column. So we can still make sure that our order form it's still intact. We still have our data integrity because we're thinking about the way things are related, and we do start getting into some of the business logic. What do we do, and how can we make sure that our data still has meaning? We haven't lost anything. We're not removing something unnecessarily or before we're supposed to or anything like that. So when we think about foreign keys and we think about what that means for data integrity, this is the sort of thing that we want to ask ourselves as we do design. So this is what referential integrity does. We ensure that data related to each other is valid. And again, we start getting to this other concept of defining rules for handling changes with the reference columns to maintain that data integrity. Sometimes we can build into the foreign key constraint itself. Sometimes we need to build it into our logic for how we're dealing with the data between those two tables. But putting the foreign key there helps us remind us that we need to do those sort of things. So next comes domain integrity. So now we're going to start talking about the columns themselves. So we're going to start with data types. Again, people normally may not put data types under domain integrity, but this is a really important thing. There are lots of hour-long sessions out there talking about the importance of sizing your data correctly. And this, when we think about data integrity, making sure we have the right data type is crucial to that because we're setting the type of data that we're dealing with. So it also creates constraints on the data that goes inside the attribute. So what do I mean by that? I mean something like a date time field or maybe a date field. So we're saying what sort of format do we want the date? Well, is it the format? Format's the wrong word. It says how much of the data we want to store. So if we're talking date time, it prevents something like someone putting 2021 or 20201, making a typo in the year and putting that in a date time field. So then we can't interpret it and we don't know what the date time is. This way we can make sure we're getting a valid date time. What if we only need the date portion? Well, we can make sure that it's the right date portion. What if we know that the date is in a particular time frame? Well, we may want small date time, or how much of the time we need to capture, what degree we need to do that sort of thing in. So that's what I mean when we start talking about putting constraints so that the data goes inside. An integer field can't hold a decimal, so we're putting constraints on those sort of things. So now we're talking about guaranteeing the valid data because of the data type that we need to do. So now we're taking our table, we're expanding it out. We can start seeing our data types that we go here. And some of the stuff we can start thinking about is, are these the right data types? For example, my gadget here, I'm looking at my description and I'm seeing varchar 254. Well, that's a strange data type for a description. Is that really how long we want our descriptions to be, or do we want them smaller? More importantly, let's look at our gadget order form and I have all these money data types. Well, if I'm dealing with stock markets or something like that, I actually care about the fourth decimal place. Those actually matter when we do calculations and when we try to calculate P&L, so on and so forth. But when I'm ordering something, and I'm only dealing with hundredths of the currency, let's say US dollars, I care how many cents. We really don't talk about ordering to the, thousandth of a penny. We talk about to the hundredth, how many pennies. So is this going to be the right data type for what we need? Probably not. We may do better with a decimal that goes to two decimal places. So these are the things to think about for our data types and making sure that we're ensuring our data is good. Not null is the next thing we want to talk about. So I find it interesting because sometimes I've seen people say, hey, talk about your database constraints, and not null is listed as a constraint. And in some ways, I was like, well, I hadn't thought of it that way, but it kind of is, because the null is an absence of a value. It is not an empty string. It is the absence of a value. So now we're setting the requirement. Does my field have to have data or not? Because there's a lot of times where you look through a table and the field is not null and you put a null in and all of a sudden the application breaks. Doing something as simple as putting a not null helps prevent those sort of issues. It also means for someone who doesn't know a database, I'm not going to try to put a null in there and break the application. It's a very simple thing, and it does have a lot of bigger implications as we deal with it, but it's a quick way to find what needs to be there and make sure, do we need to have data? So looking at our tables again, we can see something here. Remember when I said what my alternate key was for my gadget order form? Notice this field right here, our corporation ID. If you're buying a gadget, you don't have to buy it for a corporation. You can buy it just for yourself. So we need to allow null. Otherwise, we would have to create a record in the corporation that says self or no corporation or something like that. But we decided that we were going to allow it to be null. This is important because remember, originally, this was part of my logical primary key. Can't make it a physical primary key. Why? Because primary keys don't allow nulls. So now we're starting to see the interaction of how all of these different things start working together. I can't make it not null. Well, I could make it not null, but while it's null, it can't be a primary key. I have to have a surrogate primary key so I can have my unique constraint, and so on and so forth. The things to think about as we're building our tables. Next, we're going to talk about default constraint. Default constraints, I feel like, don't get paid a lot of attention to. And there's actually a Twitter conversation about this a while ago, because what does a default constraint do? It sets the value for a column if the value for the column is not specified. Now this is on an insert, or when you use a cascading foreign key set default. So if you set a value for a default constraint, or if you pass in null for that default constraint, or for that field that has a default constraint, it's going to take the null if it allows nulls because you specified what it was. If you didn't, it would then take your default. But it's interesting that it really only applies to insert or those foreign keys. There's no other reason for it to be there. But if you think about it in terms of data integrity, and you think about it in terms of the life cycle of your data, it's a cool thing to think about that default constraint, because what it does is it starts setting that default starting point for your data when it goes into a table. So you've added a definition to your data, to your table, that you may not have realized. So someone looking at the default can understand, okay, here's the starting point. So if you're talking about statuses, here's my starting status for it. And then you can go from there. So it's a really interesting way to think about it in terms of building data integrity. It doesn't mean much other than it allows you to deal with foreign keys or deal with inserts and not have to specify it. But it's something interesting to think about what it means when it talks about understanding your data and creating a little bit of integrity for columns that you may not have otherwise. So the last one I want to talk about are check constraints. So I mentioned it with data types, that kind of creates constraints on your table. This creates a different type of constraints on your column, where this creates restrictions on the data that goes into the column. So you can specify an integer column, so it makes sure that your data is only integers. A check constraint says it can only be between these values. So now we're starting to ensure the data in the field matches your given criteria. So we're really kind of, as we've gone through, we've kind of narrowed the limits of what goes into our data and what goes into our columns. And so a check constraint makes sure that we're only using those pieces of information. The cool thing that I found when I was doing research and just making sure I wasn't missing anything with a check constraint is you can actually create a check constraint not just on a column level, but on the table level. So if you're doing something like addresses, you could actually create a table level check constraint to make sure that all these fields that you need to have values or particular values or something like that, you can actually work on them together. Microsoft's documentation has some information on that. So if you're curious, definitely go check that out. I have never had a chance to use it, so I'm just fascinated that it's there. But it's a really interesting way to think about it, a different way to use a check constraint on a table level. It's kind of mind-blowing, really cool. But again, it's making sure that the data going into your table is or into that column is within that range of what's acceptable for that column. So again, we're adding another level of making sure our data is correct and only what we want. So kind of reviewing what we've just been talked about with all of those different things, because that's a lot of different things that we can do with a column to help create data integrity. So we're talking about defining the type of data that's expected. We're ensuring that the data matches what should be there. You know, is there supposed to be a value? Is there not supposed to be a value? We're establishing that common known value for the field when the record is first inserted, which is really an interesting way to think about a default constraint, right? We're ensuring that only the values we expect to find in the column are there. So essentially what we're trying to do is we're eliminating ways for bad data to get into our tables, into our columns. And so that's the main thing we try to do with data integrity, making sure that we're putting good data in there and doing what we can to help have clean data in our databases. So before we continue, any questions? Feel free to put those in the chat.
Nothing in the chat at this point, but you're doing great. Keep on trucking.
All right, so it looks like we've got 15 more minutes.
Yeah, give or take.
All right. Great. So let's keep going. So next, we've talked about data integrity. So let's talk about data integrity and performance because we're talking a lot about protecting our data. So the first thing I want to start is talking about a clustered index because a lot of times when we create our primary keys, we go ahead and make them clustered primary keys and throw them out there. One of my interview questions I think has been, would there ever be a case where you don't want to cluster your primary key? And that sort of question brings up brings up the other point of, is clustering an index, would that count as integrity or does that count as performance? So a clustered index, as a reminder, defines the order of how data in the table is physically stored. So we're talking about a physical implementation of our data. Is that integrity or is that performance? I'm going to argue that it's performance because your primary key does not have to be clustered. We tend to do it by default, and in many ways we may want to. But there may be cases where it doesn't make sense because your primary key can be non-clustered. You may want a clustered index. Clustered index, if I remember correctly, doesn't even have to be unique. But actually, and I can prove that in this next example as to why. So let's think about a person table. And a person table is one of the worst tables for thinking of how do you make a person table unique? Because it's really hard to do. You can't just use your last name because how many Smiths are there in the world? You can't do it on, you know, there's so many different reasons why you can't make it a name unique. And there's so many different things that prevent from creating a really good logical primary key on a person's table. So oftentimes you'll do a surrogate primary key, something that's meaningless, something that's not tied to something else that could be duplicated, so on and so forth. But oftentimes when you're searching your person tables, you're going to want to do sorts on something like last name. And if you think of how things work, this may be a case where you're going to have better performance if your clustered index is on the last name because you're doing it frequently. That's how things are sorted naturally on the table. It's how you're searching against the data. So what really makes each record unique, you have to have a surrogate primary key because you don't have anything better. But performance-wise, you want something else to be clustered to do that. So I would argue a clustered index is not about integrity, but it's about performance. And that's okay. There's nothing wrong with that. But it's something when we think about data integrity, we need to remember that a clustered index isn't going to create integrity. It's going to help you with the performance of your database. It's all good, but just something to think about. But luckily, a lot of these other things that we've talked about actually do help with performance. So the SQL Server Query Optimizer can use a lot of these different things we just talked about. Most of the domain and integrity, pretty much most of the constraints, you'll notice default is not there, but all these other constraints can be used by the Query Optimizer and help performance. Not only are they great for integrity, but they help, but you get the added bonus. So not nulls, primary keys, unique constraints, foreign keys, even check constraints. Um, all of these can help your queries and help SQL Server come up with better performance. In some ways, if you think about it, primary keys or unique constraints are easy ones because that way we can limit the number of duplicate records. So we have less records, again, less data, cleaner data. Those will definitely help. But I can show you, I've got some demos coming up that will kind of quick and dirty examples to show you some of these things. The other one that has a lot are data types. This is why you'll find full hour-long sessions at least talking about data types and why it's so important to make sure you size your data types properly. One thing thinking about, bloat. We don't think about data size bloat as being performance issues, but it can, because if you're always having to query an 8,000 varchar field when really what you want is maybe it's even a date time, you know, how much are you storing in your data? And if you have to index things, well, you can't do the varchar 8,000 because it won't fit in an index. Well, that gets into other sorts of things of how you create indexes, but you start running into those sort of issues. Another thing you start getting into is memory grant, because SQL Server has to figure out how much data it's holding in the memory to get the data that you want as it's doing things, and you need to make sure you're sizing things properly. The biggest one are things like implicit conversions. We've gotten burned recently because we were getting data back. We thought it was an integer, and it's actually being compared to a varchar field. So we're doing that. We're getting implicit conversions, and our performance is just tanking. And we're creating blocks and all those sort of things. Why? Because our data types are wrong, and we're mismatching things. So we have to think about how all those different things come into play, and making sure that once all of those are correct and we're consistent with all of that, that's the thing. It gets back to being consistent with all of that, that we start seeing those issues. So I've got a couple demos that I can show people, that I can show y'all. So you can see here, I have my superheroes database. And let's do this. I've got my actual execution plans on. So let's take some pretty simple examples of how constraints can be used and how we can see those in play and for performance. So we're going to start with a basic null versus not null. So I have this query here, and I'm using that gadget order form shipping. And essentially my first one is where my shipping field is not null. And I can look, and I've got my execution plan, and it's pretty much what I would expect. Now, if you notice, one of the things in Management Studio, hopefully it's enough for you to see, I've got a SQL prompt on as well as the yellow. The gray is from Management Studio itself. But if you can look, it's saying that this field is not null. So by looking at not null, it's figuring out what it's going through, and it's figuring out the information. Now I'm searching for it where it is null. So same query, changing that execution plan. But notice something, it did a short circuit. It looked at the field and said, wait a minute, you want me to find a null? The field's not null. I'm not going to find anything. It short circuits, it's done. It just does a constant scan. It returns nothing. We're all good. It's short circuit. So it made our query faster, quicker plan. We're done. So let's do something else like a check constraint. So in my schema here, we can see my gadget order form. I've got on my number of things we can order. We can order anything from 0 to 10,000. It's a common thing. Certain people have limits on what you can buy. So can order, 1,000,000 of something. It doesn't make sense for our purposes. So now let's see what happens. So I'm going to select something where we have number order equals 4 because it's between our range. I run my query. I'm getting 2 records back. And as we look, it's what we'd expect. There's nothing fancy here. Why? It's going through. All right, so what happens when my number order is outside my range? Let's execute. Nothing returned as expected. But again, SQL Server said, hang on a second, I've got a constraint here. This number is outside that valid value. Done. I don't need to do anything. And so it short-circuited and said, hey, you're done. Here's your data. Nothing. Quick way to think about things like that. So let's move on to something a little more like primary key constraints and thinking about those. So we have something here. My person ID is 10. So I'm going to do a search on my primary key. It's pretty simple. We can see that it is doing I clustered index seek. And when we start looking at things like the estimated rows, we can look and we say a number of rows for all execution 1, estimated note. It's more this estimated number of rows per execution 1. It knows it's a primary key. It knows I'm searching for something 1. It's going straight to it. It makes it quicker because it knows what it needs to search for. So these are ways that we can kind of see these different things working and how we know that it's looking for what we'd want it to look for, and it can use that primary key to figure these things out. So let's start looking at unique constraints. So let's start looking where we're not quite seeing the data that we'd expect to see. So I'm in a superheroes database. So I have a villain schema for those schemas which aren't so clean, a little villainous. So I'm going to create a table for equipment. And I'm going to put stuff from my gadget table, and I'm going to put a null in as well. So I have 34, so I now have 35 records. So I have one null value, because remember, in a unique constraint can allow nulls, but it can only exist one time. So I'm just going to look for that null record. And if I look at my execution plan, I am doing an index scan. We know there's only going to be one row there, but it doesn't know that. It's reading all 34 rows because it's doing a scan. It's not a very big table. So now let me create my unique constraint. So same statement again. I have my record, but now again, it can do that unique key, can do the seek, but again, it also does the number of rows read, the estimated number of rows read. It already knows that it's only going to exist once. So again, it can already jump to the fact that I'm doing a search on something, it's one. So we could actually search for something else. So let's say we wanted to do umbrella. I think that's in here. All right, we have an umbrella as a gadget. Again, we can do the seek and see the same thing. It already knows that there's just going to be one value, so it can just jump ahead. Yep, I'm only looking for one thing. Again, this also gets into how SQL Server decides seeks over scans, but you can also see that it's using those indexes and using those constraints, because remember, a primary key constraint and a unique constraint are also indexes. So it's using those indexes as well. So just a quick little example of that. So now let's talk about foreign keys. So I've got this table right here. This query, I'm looking my villain gadget order form, and I'm joining it to my person table. So right now I want to do this, and I want to get my first name, last name from the person table, and everything else from a gadget order form. It's a very simple query, and if we look, we can see that it's joining between the two. We see our order and we see our person. So now I'm going to run this, and I'm going to comment out my first name and last name. So what am I getting at here? So SQL Server Optimizer can figure out that if it doesn't need something from a table, it can eliminate them. So we don't need to pull anything out from that table, and it'll skip things. So what I've got here is I'm going to call out these two. So pretty much everything I now need is from the gadget order form. And if I look at my execution plan, well, the person table is still there. Well, I don't have a foreign key, so let's add my foreign key constraint. That's there. So we can prove it's there. It is. So now we can do our select. This is the same select statement. First name, last name commented out. Hang on, person is still there. So part of what I'm talking about is this foreign key. What's supposed to be happening is SQL Server is supposed to recognize there's a foreign key between these two. And Hugo Cornelis, who was doing execution plans earlier today, has a blog post talking about how SQL Server will filter things out when there's a foreign key. So we shouldn't be saying person. Grant Fritchie, who's also does so much and written the book about execution plans, has talked about the same things. If you have a foreign key in place and you're not using it, SQL Server should know it doesn't need to look at the person table. I'm doing a join here. What's going on? Took me a while to figure this out when I first put this query together, but it has to do with this person ID from the villain gadget order form. It's null. So SQL, because I'm doing an inner join, SQL Server can't figure out, well, it's only supposed to have a match. It doesn't know that to trust the foreign key because it's a nullable field. Is it there? Is it not? I'm curious right now, what happens if I make this a left join? Left join, hey, it doesn't care because it's null. We don't care about anything from the person table. But because we had it as in join, it does matter. So now that we know that it's a nullable field, person, yes, let's make it not null. Now when we run our query as an inner join, we can now see it does the same thing as if it were a left join. So now we have null abilities coming into the play when we talk about foreign keys, because it can use the foreign key to say, hey, I don't need this. When it's not null and you have the foreign key, it knows it can trust the inner join to the other table. Here it can't. So I'm going to reset everything. And just a quick example for data type implicit conversions. So I have this query here, my villainous query. And if we start looking at different things, we can see different things that are caused. Like we have an implicit conversion. We see the yellow thing here. I'm sorry, it's maybe a little small on your screen. But we can start seeing things like an implicit conversion affecting our cardinality estimate. So now we can start looking at properties. If we go to our properties, which is over here, we can start looking at memory grant info. How is this working? Do we have memory feedback? We don't because it's the first time. We can start seeing things like we have compute scalars and what these sort of things are doing, all because it's having to do implicit conversions on our data because our data types don't match. For the record, I do have this demo query. It's going to be up on my GitHub, so you'll be able to pull this down along with the superheroes database I'm using. So you'll be able to play a little bit more. But as I'm coming near the end of time, I want to jump back over and just kind of leave you with some parting thoughts. I don't see any questions here at the moment, but some parting thoughts. Is data integrity 100% achievable? Unfortunately, no. Our data is messy, and so our data integrity is going to be messy. Our databases are going to be messy. But if we figure out what is needed to really create that data integrity, we're in a better position to understand our data and a better position to work with our data and figure out how to deal with those issues that if we can't implement it in our database, we can try to do what we can to achieve it. So for things like this one that what I was talking about earlier, we can now go back to see where it fits into the bigger picture. And we can see it's something that we ordered. It is a number ordered. So we can now see that, yes, I ordered a Wonder Woman tiara for myself because, we should all have one. But I can also make sure that that number ordered always means what it is when it is in that column on that table. And now I understand what it is. And I can make sure it still maintains that meaning. So I have a lot of references for people, and I will make my slides available on my GitHub as well. And I do want to say thank you all for coming so much. This is my contact information. And there's speaker evaluations. I'd love your feedback. Hopefully this has given you a little something else to think about how we can build a little bit of data integrity and the little things we probably already do to put that in our databases and things we can build upon. Any last questions?
Doesn't look like there's any questions coming in, but you do have some kudos in the. Oh wait, no, there's a question. The question is, what do you think about foreign keys on transactional tables in high-loading OLTP environments? I mean, in high-loading OLTP systems, there are a lot of anomalies which are hidden to an ordinary OLTP system.
So this is where we start getting into that integrity versus performance and reasons why we may not be able to put everything in there. It's why, like, a lot of warehouses, people used to say don't put foreign keys in because it slows down loading of things, and again, this always gets into the big it depends, which is, I know, the least favorite things. How you deal with locking, how you deal with foreign keys in the overhead, again, it is why a lot of people don't like it. When we talk about different things, there are different there's so many different things you can try in terms of pessimistic locking. Do you want to try optimistic locking with recommitted snapshot isolation? I don't know if that necessarily works for your situations. Um, yeah, having to drop foreign keys and re-add them, this is a tough one because, again, people don't, it gets into the performance versus integrity, and your system's going to vary. And this is why I say you can't always do it, but it is important. If you have load times, maybe what you're doing, dropping the foreign key, re-adding it later, but again, making sure the integrity is there, because as you can see, depending on how you're querying stuff, um, the foreign key will make a difference. It can help with performance. Grant Fritchie definitely has some really great examples showing that. It depends on how you're building your system. Unfortunately, I don't have a better answer than that. But yeah, this is why a lot of times we have to be careful about how we implement integrity, and thinking about integrity versus performance and understanding the two. And sometimes integrity takes the backseat to performance. Yeah, I don't have a better answer than it's, it sounds like you're doing what you can with those different things. But as long as you're doing what you can to make sure that the data is in sync later, um, you're building in the things to do it. So I hope I hope that works. Okay, good. Thank you. Any other questions?
Doesn't look like there are any other questions at this time. So
Okay.
with that, we can kind of wrap things up.